So today we are doing an interesting question on exponent and power previously asked in Maths Olympiad. So in this, we are given this particular equation and we have to find the value of x. So to start with, we'll first factorize each term. So 6, we can write 6 as 2 times 3 raised to power x. 8 is 2 times 2 times 2 raised to power x. 15 is 3 times 5 raised to power x. 9 is 3 square raised to power x. 10 is 2 times 5 raised to power x. 12 is 2 square times 3 raised to power x. So here we can write simplified. So this will become your 2 raised to power x times 3 raised to power x plus this is 2 cube raised to power x. We can also write down as 2 raised to power x whole cube plus 3 raised to power x times 5 raised to power x. This is 3 raised to power x whole square plus 2 raised to power x 5 raised to power x plus 2 raised to power x square times 3 raised to power x. So here we can assume that for our own simplicity, we can say let 2 raised to power x is equals to a, 3 raised to power x is equals to b, and 5 raised to power x equals to c. So putting these variables here, we'll get this as a times b plus a cube plus b times c. This is equals to 3 raised to power x is b. So b square plus a times c plus a square times 3 raised to power x is b. So we have just simply done is wherever 2 raised to power x is there, we have replaced it with a, 3 raised to power x with b, and 5 raised to power x with c. To simplify it, we are taking everything in LHS, and in terms of a, we are writing it in descending order. So highest power of a will be first, that is a cube. Then will be the a square terms will be there. So minus a square b, right? So these two terms we have written down. Then we can write terms in form of a. So we can say a times b. So plus a times b. Now here I'm writing minus b square. Then plus b times c minus ac. This is equals to 0. So this AC is on the other side is becoming negative, and this BC, that BC is here. Now to simplify it further, what we'll do is we'll make them in pair and take out whatever common we are getting here. So from first term, I'm getting a square as common. So a square times a minus b plus b is common. Inside is a minus b. Now here in the third term, I want a minus b to be inside. So I'm taking c minus c common. So inside is a minus b again equals to 0. So I'll take a minus b common from all the terms. So a minus b times a square plus b minus c equals to 0. So here in factorization, we know that out of these, either a minus b will be equals to 0, or we'll have a square plus b minus c will be equals to 0. Putting the values of a and b which we had assumed. So these values we'll put here. So we are getting here a is 2 raised to power x minus 3 raised to power x is 0, or this is 2 raised to power x whole square plus 3 raised to power x minus 5 raised to power x is 0. So from these two equations, we are going to get value of x. So this one is 2 raised to power x is equals to 3 raised to power x, or 2 raised to power x by 3 raised to power x is 1, or 2 upon 3 raised to power x, this is 1. We know any number raised to power something is 1, then that number has to be 0. And this is our first solution, that is x is equals to 0. Let's check from the other equation what we are getting here. So 2 raised to power x raised to power 2. So we know that if we have a raised to power m raised to power n, this is same as a raised to power n raised to power m. So here we can interchange this x and this 2. So this is same as 2 square. This will be same as 2 square raised to power x. And 2 square is nothing but 4. So simplifying it, we are getting it as 4 raised to power x plus 3 raised to power x. This is equals to 5 raised to power x. So from Fermat's last theorem states that if a raised to power m plus b raised to power m is equals to c raised to power m, then only solution possible is when m is equals to 2. There is no equations where you can have m as 3, 4 or 5. You cannot have something as like 15 cube plus 19 cube is equals to 21 cube. Like that you can never have an equation. This equation is possible if and only if m is 2. That's your Fermat's last theorem. So using Fermat's last theorem, we'll get here x is equals to 2. So for our given equation, we have got two solutions are there. One is x equals to 0 and another is x equals to 2. So this is your complete solution. I hope you enjoyed the question and its solution. We'll see you in next video. Till then, tata, bye bye.